Okay, so in Google Classroom, you'll see it's here. It's due September 22nd. That's a week from today. Okay, so you have lots of time to work on it, come in and see me for help and ask questions, including Monday of next week if you need to. All right, so in there right now is obviously your document. Okay, that's the one you'll be working in today, so the Google Doc, right? There's the lab sheet that I'll be working off of, but you have it there for the procedure and everything. And if you're not in class today and you can't actually perform the lab, then there's a set of data here that you can use to get your lab completed. Okay? But for the rest of us, obviously, we'll have our own data. All right, so the setup of this lab is going to be pretty straightforward. Make a ramp. That is, take one of those tracks, put it on something so that it's got a moderate incline, okay? That means like at the most 20 centimeters off the ground at the high end. It does not need to be at a 70-degree angle, okay? And in fact, if you, like, I always have people who start out by putting it on the seats of the desk. That's way too high, okay? Way too high. 20 centimeters for the maximum height of that ramp is lots, okay? Because the steeper you make it, the faster, obviously, it goes down the ramp, and the less data you get. Okay? Having just a moderate incline means it's still going to accelerate, but you're going to get more data, and the more data you get, the better your analysis can be. Okay? So, the problem we're investigating: what type of motion is experienced by a cart rolling down an incline? Gosh, I don't know. Might have something to do with the title. Okay? Obviously, it's going to be accelerated motion. Okay? So for our design here, the purpose of this lab is to work on acceleration, but also to get experience using velocity versus time graphs, as that might help you a little bit with your design. Okay? Because we just talked about a minute ago, whatever's on the graph is usually two of your variables. All right? So since we're determining how long the experiment can run for, we're effectively going to be determining how much the velocity of the cart can change. Okay? So we're determining how long the experiment runs for, and the final velocity, or the change in velocity of the cart, will depend on that, or respond to that. Okay. Controlled variables. We want the acceleration of this cart to stay the same throughout the entire experiment. Okay? We want it to accelerate, but we want that acceleration to be uniform. So we don't want it to accelerate faster at one point and slower at another point. Okay? We want the acceleration all the way down the ramp to be the same. So for your controlled variables, you need to think about anything that could cause the cart to change its rate of acceleration. Okay? We don't want that. Right? So anything to do with the ramp that you want to have stay the same the whole time the cart is traveling down needs to be a controlled variable. Okay? Even something that you really can't control but won't change, but might affect the rate at which it goes down the ramp, could be considered a controlled variable. You know, that thing that's holding you to your desk right now. Force is always bringing you down. Might be a controlled variable. Okay, for our hypothesis, what three words need to go in our hypothesis? If, and then. All right, the if part has to be about the premise of the experiment. The premise of this experiment is that an object that's accelerating is changing its what? What is acceleration? A change in velocity. There's your if part, okay? Should probably tell me what acceleration is. Okay, what is acceleration? That's what the if part needs to be about. So if acceleration is blah, blah, blah. Okay, the and part, as always, describes the experiment. Cart runs down a ramp while some things are recorded. Don't say some things, tell me exactly what. Okay, and in the then part, okay, how will you calculate the acceleration of the cart from the velocity versus time graph? Gee, this is an a lot like the last lab. Okay, except this time we're finding acceleration. Okay, for your data, same as the last lab. I want your chart and I want your graph. Okay, and you're going to have a velocity versus time graph. You're also going to have a position versus time graph. Okay, you're not going to use the position versus time graph to calculate anything, but you are going to use it to help you verify what type of motion the cart is undergoing based on its shape. Okay, so you won't actually be calculating, oh, that's not true. You will calculate displacement from that graph, but that's easy. It's final position minus initial position. Okay, but you're basically just using it to get the shape to tell you what kind of motion is going on. Okay, do we know what kind of shape it should have if it's accelerating? Right, position versus time graph. Okay, so you're going to have those two graphs plus your data chart. So your data chart is going to contain both position and velocity data, okay, for your one run. You're only doing one run here. Okay, so you're going to have the position, the time, and the velocity data in your chart. Okay, so for the analysis, okay, first off, first question, using your graphs, identify the type of motion that occurred. That means talk about the shape of your two graphs. What does the position versus time graph say is going on? What does the velocity versus time graph say is going on based on their shapes explained? Okay, and show calculations to prove that. Okay, that is calculating the velocity from the v versus t graph, or sorry, calculating acceleration, sorry, from the velocity versus time graph. Okay, so that will be your proof. Okay, showing your calculation of velocity, acceleration, I keep saying velocity, sorry. Calculating your acceleration from your velocity versus time graph. Okay, so two things in question number one. How do the shapes of the graphs tell you the object is accelerating? Calculate the acceleration from the velocity versus time graph. Okay, question number two. With your graphs, there are two ways to find the displacement of the object. All right, we just talked about from the position versus time graph, it's just final position minus initial position. Just do that calculation. Okay. You also need to calculate it from your velocity versus time graph. We went over that in class yesterday again. Okay, there's a way to calculate that. Actually, two ways to calculate it. Okay, from your graph, and then I want you to compare your values. Theoretically, they should be, if I calculate displacement from my position time graph and I calculate displacement from my velocity versus time graph, theoretically they should be the same. Okay? Are they going to be exactly the same? Probably not, but they should be close. Yeah, they should be reasonably close. Right? If you're off by 1.5 meters, you did something wrong. Okay? You should be within, let's say, 10 to 15 centimeters, right, when you do that calculation. All right, that's the two questions in the analysis. You need to show me your work for that. Obviously, that needs to be in your lab report. If you do it on paper, take a picture of it and insert the picture. Okay. Then for your conclusion, copy and paste your hypothesis, and then based on the shapes of the graphs and the calculations you performed, did the object undergo accelerated motion? Can you accept your hypothesis? Okay. Sources of error, okay. Identify two sources of error and ways to fix them. They could be similar to the ones we talked about this morning for the last lab. Okay? We are, after all, still dealing with a cart traveling along the same type of track. All right, you don't have to do the class discussion. We'll talk about those in class together when I return the labs. Any questions on what we're doing? All right, so acquiring the data shouldn't take you very long. You set up the ramp, run the cart down, collect the data on your phone, send it to the group, and then you can sit down and get going on the lab report and have the rest of class to work on that. Okay? The columns you're going to keep are time, position, and velocity. Because you're still going to get those other columns that you don't need. Okay? You only need time, that should be your first column, position, and velocity. Okay? I'll show you a little bit of tips and tricks for the graphs once you guys have your data. Okay? All right, let's get to it. Okay, so obviously I don't have very much data here. My chart is really small. Yours is going to be much longer than this because your data is within the cards. Okay, but I can't, I have to graph these two things separately. Okay, so the first thing I want to do is do my position versus time graph, which is just highlight the time and position data. Okay, go to insert charts, okay, do all of that stuff, same as we did before. Okay, you want a scatter plot, obviously not a column chart. Okay, oh, and I've got this fun thing here where it didn't determine what the x-axis was, so I have to tell it. Okay, and I want to take time off of there. Okay, so I get this. Now, because I don't have a lot of data, it doesn't look really curved, but it is. Okay, it is curved. It is showing me that the position is increasing exponentially. Okay, and then I would go in and fix all of the other stuff. Now, the other thing I need to do is I need to make a velocity versus time graph. The easiest way to do that is actually to make a new sheet. So just add sheet, and then copy the time column over and the velocity column over. Rather than try to highlight them separately, it just kind of gets weird when you try and do that. Alright, then I highlight that data, insert my charts. Okay, same as before, so I've got a weird one here. I probably should have put a 0 in there, but okay. Actually, I definitely shouldn't have put a 0 in there. Okay, and I can get my line drawn and all of that kind of stuff from there. Okay, when you're drawing your line on the position versus time graph, okay, and it's asking you, to do the trend line, obviously we want it to make a curve. So when you go to series, okay, you want a trend line, okay, but it's not linear. You want an exponential one, okay, so it draws a curve for you. Like that. Okay, your data will be more curved than mine because you have more